right, so my talk is going to be on Wireshark, my favorite Wireshark customizations. Sorry, I'm going to be coughing a lot too. So Wireshark is a really great tool. The thing I like about Wireshark, and the thing that most people like about Wireshark, is that it's free, right? Having a free tool is pretty great. I won't say that it is not a professional tool, because I think it is a professional tool. Many professionals use it and rely on it around the world. The main drawback with Wireshark is they haven't had a lot of, until recently, they haven't had a lot of native support or support for like the internal NIC on your device, right? You can't use your internal NIC on your PC, for example. You can do it on a MacBook just because they use BSD. They only have like this many NICs to choose from. It's easy for them to say, I'm going to put this in RF monitor mode and use it. So for Windows, it's kind of been a drawback for a while. To do that. Oh, by the way, this is me and this is where I am. It's kind of been a drawback on using it because you had the only requirement, or the requirement was you had to use this expensive NIC called an Air PCAP NX, and it was really expensive. You can get them now and they're still, you know, $800 on eBay if you look them up. So recently with 3.0, they introduced native support for certain chipsets. So I've been using the Netgear 8 6210 to do packet captures, but even cooler is that recently the wireless LAN Pi can be used for doing packet captures on Windows and Mac. So that's pretty great. So we're going to learn how to do that if you take the wireless LAN Pi course, and we're going to talk about it today in the Wireshark deep dive as well. You can use the Sidekick. That's multi-platform, so you can use that as long as you have Ekahau Connect. You can use that. You can do multi-channel captures in Mac, but the only way I know to do it right now is using the Ekahau Sidekick. You can do up to 2 channels simultaneously. You can, with their tool, do more than 1 channel, but it just starts hopping channels, and you don't want to do that when you're doing a packet capture. So really 2, I would say, is the limit on Mac OS. Now Windows, while we have no native support and we do require third party, you have been able to do packet captures pretty well on Windows. It just costs you money, right? You have to have, if you have Wireshark, you have to have some kind of hardware device to connect it to, and it's always been expensive until recently with the Netgear and 3.0 with the other chips that you can use. You've also been able to use tools like OmniPeak and ComView, which are great tools to use, but they tend to be expensive, right? The main difference to me between Wireshark and those tools is that those tools have taken the time to make things a lot easier, to do analysis a lot easier, where Wireshark, you kind of have to fight with it a little. You have to create filters and set it up the way you want it to see the things you want to see. So that's, to me, the biggest difference between Wireshark. But the fact that Wireshark is free and easily available also makes it, to me, one of the best tools to use, especially when you're getting into wireless packet captures. So again, the wireless LAN Pi also available now for Windows as well to do those packet captures in Wireshark. Now, there are multi-channel options. Mainly, the easiest way to do it is with other applications like OmniPeak, for example. You can do, I mean, Peter McKenzie does, he's telling me he's doing like 20 channels at a time. He can do packet captures on 20 channels at a time going into OmniPeak. You're not going to be able to do that with Wireshark, right? So Wireshark is not going to, I don't know how many people are doing those kinds of packet captures, but you're not going to be able to do that. There are other options. I have a blog post that talks about different options for doing packet captures in Windows. So let's get into what is available to do in Wireshark. So the first thing you need to do, and anybody who gets started in Wireshark, this should be the first thing you do, is create a profile. Now the good thing is you can create multiple profiles. You can't even do this in OmniPeak yet, where you can actually create profiles, just a little drop down. You can say, hey, I'm troubleshooting 802.11. So you bring up your 802.11 profile, and it has all your columns and the colors and everything you want it, so I can troubleshoot 802.11. But maybe you're saying, hey, I want to troubleshoot voice over Wi-Fi. Do another profile, and all the columns change, and they get only the columns that matter to you about doing voice over Wi-Fi, or whatever it is that you want to do. I even have one that I call review that I use just to go over frames with customers, because my customers look at this and it looks like like gibberish. They look at this like, what is all this stuff? It means nothing. But I put on this review profile. It cleans everything up. It only has like 5 columns. It has my little comments, and I can show them and walk them through a problem to where they understand it, right? So I like the fact that this is one unique aspect that Wireshark has over some other tools, is that we can create these profiles. And the profiles are really, really straightforward to create within Wireshark. It's just a matter of right-clicking here, clicking new, type in the name of your profile, and literally you're done. You have created a brand new profile. Then it's just about customizing the profile the way, and we're going to talk about how to customize it. And like I said, the cool thing is when you're in a profile and you're customizing it, all those customizations stay with that profile. So when you go to your next profile, those customizations are gone. They're in the old profile. You can just set up new customizations in that one. And if you want to go back, you just click on the bottom here, select the profile that you want, and boom, you're back into your profile. So profiles are very cool for so that you can see what you want to see when you want to see it very quickly. Columns. Now, columns are very nice because they allow you to know what you're looking at very quickly, right? So we can see everything from source address to destination address. You can also put transmitter address and receiver address, because you know we have up to 4 addresses in Wi-Fi. You can have the frame type, so you can have a column that actually tells you this frame is this type of frame, right? You can actually see the data rate, the NCS, the spatial streams that was sent at. So if you have a device that you're like, this is a 3 spatial stream device, but it's always sending at 1 spatial stream, you know, that could maybe say, okay, maybe something's going on that I need to look at. You can see stuff like the SSID. These columns, most of these columns by default aren't there in Wireshark. You have to create them. So in Wireshark, it's very straightforward to create a column in Wireshark. You can simply right-click and select your columns from here, but by default, Ekahau. I always want to say Ekahau. I meant to say Wireshark, because I'm teaching Ekahau all the time. By default, you only have a very small subset, and they're all pretty much pertaining to Ethernet. So you have to create your own subset of columns. So the easiest way to create a column is you go into a frame that you want and you find the thing that you want to create a column for. So for example, if I wanted to do SSID, what I could do is I could look for a beacon. So over here I have a beacon frame. I know it's beacon because it says beacon in the info here. And then I can say, you know what, it's a beacon frame and I want to look for SSID. So I'll go down here and look for the parameter SSID. So right here is the SSID and it says EW internal. So I can just apply as a column, and boom, now I have a column called EW internal, and now, or a column, sorry, called SSID, and all the other SSIDs that are being broadcast there as well. If I go to a different profile, notice I get different columns, right? Because the columns are saved, it's part of that profile. So now I have a column here called SSID. Creating columns is a very nice thing. You can move them around. You can say, I want the column over here or over there. And the other cool thing is you can create as many columns as you want. And even if this becomes really busy and you say, man, I got too many columns here, well, that's okay. Maybe today I don't need to look at SSIDs. I can just uncheck that. And the next time I'm like, oh, you know what? I need that column for SSIDs. I right click and I can say, oh, there's my SSID column. So you can create as many, because I don't use all the columns that I've created all the time. Here's my profile that I use most of the time, and if I right click, you can see I have lots of stuff that is there, but I don't actually have it enabled. Like AMPDU, I don't really need a column called AMPDU, except every now and then I may want to see that for some reason, right? And so there's various columns, very useful for when you're trying to understand what you're seeing, very useful when you're trying to learn how Wi-Fi works and what frames come before other frames, what frames are acknowledged, what frames are not, because then you can see, oh, this is a beacon frame, this is a data frame, this is an acknowledgement frame, and it kind of gives you a good understanding of how the protocol works, right? So columns, very cool. Colorizing packets, probably one of the easiest Wireshark hacks that you can do, right? Is colorize your packets. So right here, I don't have them colorized. If I just click on this button, I have them colorized. Now, normally there are no colors in Wireshark. So if I go to my default profile, I have colors turned on here, but there's nothing showing up because I don't have colors. So I would have to go into my view menu, and where it says colorize packet list, that's the same as hitting this button. Over here is colorization rules. These are the rules that exist because by default Wireshark was designed for wire, for Ethernet. So they don't have any of the Wi-Fi stuff in there. So what you need to do is you need to add something that you want to color. So for example, if I wanted to, for example, let's say, here's a data frame. I know it's a data frame because I have my column, I have in the info it says data right there. So I can go down here and I could say, you know what, what's a data frame? What is it that I'm looking for in a data frame? And here is the subtype data. That's what I'm looking for. So I could say, let me see here, that's my filter. So I'm going to grab that filter. I'm filtering for only data frames. Now I'm going to go to my coloring rules, and I'm going to create a new one. And I'm going to say up here, I'm going to call this data, and whoops, data with an A. And I'm going to paste that filter that remember I just right-clicked and said copy as filter. Now I'm just going to go back and enable it. And now I should have blue. Oh, I don't because I'm not colorizing it. And
it's in your rule, but you didn't give it a color.
oh, I didn't give it a color. I'm tired, guys. Okay, so I'm going to give it a color. Sorry, I'm going to click. I'm going to get that blue color or purple. What do I got here? Blue. I'll give it a nice bright blue, and I'll give it a background of black letters so it stands out. Or maybe I'll give it white letters so it stands out better in contrast. And now my data packets only are blue. So now I got blue data packets. So you could do that one at a time and get something that's more colorful. But the problem is you don't want to have to go in there. Actually, let me get rid of. There you go. Now I'm seeing all my frames. But I don't want to have to go in there and do that manually. That is going to take forever to do that. So what I've done is here, or what MetaGeek has done, I put a link here to what MetaGeek has done. MetaGeek years ago, when they came out with IPA, they come up with a color scheme for IPA, and they said, well, why don't we just create one for all the frames? And so they actually went through, and I'm not connected to Wi-Fi, I guess, so I'm not going there. But if you go to that link to MetaGeek, there's a little file that you can use. It's a color file that you can share, you can edit, you can make it all your own. And if you download it from here, so this was posted by Joel Crane years ago, and you can actually take that file and install the MetaGeek profile if you want, or you can just take that color profile and put it in your own profile, restart, and boom, now you have colors in Wireshark. And it makes it very cool because you can very easily see, wow, I got a lot of data, I got a lot of control frames. And again, you can kind of see, like over here, I can see RTS, CTS, data, ACK, RTS, CTS, data, ACK. That's normal Wi-Fi. If I saw a bunch of data, and ACK, I'm like, well, what's going on? Why am I getting a bunch of retries? How do I know I'm getting a bunch of retries? Because every data should have an ACK. And if I got 50 datas and one ACK, I'm getting a lot of retries. But what if I get a bunch of datas and a block ACK? Well, that's normal Wi-Fi because now we're doing block ACKs for a series of data transmissions that were made from this device, and it started that position by requesting for that block ACK, right? So you can visually, really quick, see what's going on in your packet flow. So colors, another thing that's very cool. Custom display filters. This right here is the meat and potatoes of Wireshark. This is where stuff really starts getting real, because you can start not only saying, okay, great, I have a bunch of colors. What does that mean? A bunch of yellow, red, orange. Okay, great, Eddie, I can tell, but data ACK, data ACK, data ACK. But I really want to know what this device is doing. My customer's saying the CFO's iPad cannot connect to the AP. Why isn't the CFO's iPad connected to the AP? Your Wi-Fi sucks, but everybody else is connecting. Why does your Wi-Fi suck? Well, let's find out if our Wi-Fi really sucks. I can create a filter for a specific device, and I can say, okay, CFO's iPad, let's figure out what your MAC address is, and I'll create a filter, WLAN.ADDR equals, and the MAC address, and now if I put that in the filter field in Wireshark, it will only show me frames that contain that MAC address in them. That's cool, but then I want to see, well, but the iPad may be talking to several things. Maybe I just want to see and I can also see everything that's out there. Maybe I just want to see frames from from that iPad directly to the AP. So I create another filter, maybe called CFO AP, and I'll do WLAN address equals MAC address, and then I'll create a combination of filters, right? So not only can I do clients or frame types, I can say I can combine a bunch of stuff, like retries and the MAC address from the CFO's iPad. And then I can see, well, what's this iPad doing? How many retries does it have? Those kinds of things. So it gets to be really powerful when you can do stuff like that. Because I have filters already set up for myself that I have. So for example, if I go to this packet capture here, I, for example, can say, show me only frames with my MAC address from my phone, and I can see, oh, there's AP and there's the client, there's the AP and there's the client, so I can follow the flow of my device talking to the AP. And you can do this for any device that has a MAC address, and if you want to detail and dig in, and when we go in a little further, we're going to see that this is going to come really handy. So again, filters for clients, filters for type of frames, and combination filters, right? So more than one thing, right? In this case, this one is just simple RTS and CTS only. It's just a simple filter there. All right. So searching. So searching is pretty cool because searching allows you to, notice how you remember how I made that column earlier. I actually went down here, I found the field that I wanted, and I right-click and I said create as column. But sometimes we may know exactly what we want, and we can find it really quick without having to dig through the field. For example, we could say, let me see here, let me find a beacon here, for example. Well, I can do Control F and bring up the search function here, and I could type in, for example, SSID maybe, and then I can say it's a string, and this is the packet list. Maybe I say I don't want to search here, I want to search here in the packet details. Show me where SSID exists, and I can go to there, and it takes me to the SSID parameter, and so now I can use that to create, say, a column or a filter for SSID or something like that. Very, very cool stuff that we can do, and it allows us to very quickly start building out our profile of what we want Wireshark to show us. All right. Here's, we're just going through the different things where you can, how you search for that and what you can find. All right, custom name resolution, another one of my favorite things in Wireshark. It allows me to actually, instead of seeing this, just this kind of stuff, and I have to remember, oh yeah, my device is ACE6, and I'm like, oh man, I gotta remember that stuff. Or if you're trying to tell someone or go over it with a customer and say, oh, see this device, AE6, that's your device. Remember that number, because we're gonna come back to it. It's a lot easier to just say, your phone's called Firefly, or I can call it Bob or John or whatever I want to call it, and it's very easy to say, okay, now Mr. Customer, let's take a look at this, right? It's also easy for me just to learn stuff and to remember stuff. It's easier for me to do this. And this is a very cool little quote-unquote hack in Wireshark that you can do. The way you do this is there's something called an ethers file, and it's very easy to get to. You just go to Wireshark, about Wireshark, and there's a little folders tab, and right here is your personal configuration. That's where all this cool stuff is hiding, on the personal configuration. If you click in there, it takes you to a folder. It's the same on Windows and Mac. It's the same folder. And then you notice there's a file called ethers. And if you open that up, the ethers file comes up, and you can, in here, think of it as a host list. That's essentially what you're doing. You're saying, instead of an IP to a name, you're saying, here's the MAC address, and whenever you see this MAC address, replace that MAC address with the name that I'm calling it. And now, when you restart Wireshark, you get names instead of MAC address, and so you can say for a specific item, I want to see everything that has that. You could also, as I showed you before, you can mix and match. Show me if is my device probing? Yeah, there's my device probing. So if you're learning the CWAP and you want to go through and kind of analyze how does a client probe for devices, how does it associate, what's the whole process, you can do that by simply doing a filter for your MAC address. And if you want it just to look nice and easy to read, change the MAC address to your device's name, and now you got something that's really easy to look at, right? So when you're talking to a customer and you're saying, hey, Mr. CFO, your iPad is having a problem. See how it's it's doing an association, it's getting an association response, and then it's doing a deauth to the AP, and then we're getting a response code that says, hey, it's unsupported feature set. All of a sudden that tells me that, oh, this device can connect to the Wi-Fi, but it doesn't like something on this Wi-Fi, a feature that's enabled, 802.11k, 802.11v, 802.11r, right? I don't know. And it's saying, you know, and the driver, whoever made the driver said, you know what, if you don't support this if you have an unsupported feature set, instead of staying connected and just not using that feature, which would be a cool thing to do, I'm gonna say just disconnect from the Wi-Fi and don't join it at all, which is a problem that I've actually seen with a customer where they had a slew of brand new devices that wouldn't connect to their network, and that was because somebody had read in a blog that 802.11k is a good thing to have, and it is, but they didn't test it, they just enabled it, and their new devices, the driver said, hey, we don't support K, so we will not join if you have K. And I was able to find that because I was able to look at how this device was getting on and off and seeing where did it fail, where did it not connect properly, right? So naming, very cool feature set that I like. We also have, if this will move, thank you, the ability to save frames. I don't mean save a file. We all can save PCAP files. I'm talking about saving particular frames out of something else and comment on those frames, right? Why would I want to save only particular frames? Well, a lot of reasons could be for studying, right? Again, if you're looking over if you're learning the CWAP, or if you just want to learn about Wi-Fi, how Wi-Fi works, instead of looking at 10,000 packets and trying to figure out what's going on, maybe you can say, hey, I only want to find my device, and I only want to see the probe request and the probe response and the association request and the association response and the four-way handshake. I want to see how that all works. Or I'm doing .1x and I'm learning how that works, and I'm going to only want to see the same thing, except I also want to see the EPOL transmissions, the exchange, and the four-way handshake on this as it's connecting. So instead of doing 10,000 files and creating a filter string that's this long to only show me what I want, why don't I just find the frames that I want, I'll mark them, and I'll save them to a separate file, and now I have something I can refer back to or show a customer if you're troubleshooting, right? So the way we do this, fairly simple. I'm going to turn off the color so it's easier to see. You select individual files. You can right click and you can mark a file. So you can mark that. So you can see if I move away it's black, that means it's marked. You can also do Command M or Control M, either one, Control M on Windows, Command M on Mac. That also does it. So if I just keep doing Control M, and I can do various frames, right? I can pick only specific frames. Now I've marked them. So now they're separated from all the other frames. Now what I can do is I can save that. So what I'll do is I'll save as, I'm sorry, not save as, export is what I meant. Export specified packets, and then I'll call it, I'll just call it test, and I'll say marked packets only. Just the packets that I marked using that special Command M or Control M. And now I can save it as test. And now, if I go to that same folder, I should find a test PCAP. I can open it up, and now I have my frames. But here's where it gets even cooler. Let's say I'm showing my customer something, and I want to reference each one of these so I can walk them through. So basically what we're doing is we're taking something that's really advanced and complicated and gobbledygook, and we're going to try to convert it into something that makes sense to maybe someone who doesn't have the same insight and the same understanding as you do. So you can comment on a frame. So I can right click on a frame, and I can say packet comment, and I can say this is a packet, and I can enter, and I can right click and I can say this is another packet, right? And I can do this for every single frame that I want to comment, right? This is yet another packet. It's actually frame, but we'll just go with packet. But all right, now we don't see anything, we see them down here, not very helpful, but hey, I learned how to make columns. So why don't I make a column for comments? So I'm going to open this up down here because I noticed if I click on a frame that I don't have a comment, nothing's there, but if I click on one that I did, here's one, and I can actually say right click, apply as a column. And now we will have a column called, sorry, over here. It's all the way over here. Comment. I'm going to move that over here. Boom, boom, boom. So it's easier to see, closer to where we want to be. And now I actually have comments for each one. So what you can wind up with is something like this. So I created this for the last, my last talk, and this is basically, and also I have a profile called review that takes away all the columns I don't need and leaves only the ones that I want. So it's a lot cleaner. And now we can see an EPOL exchange. So we can see how a device actually does this transmission when it's doing .1x. So we can see the AP is the authenticator, right? The AP says, who are you? And the client's like, yo, it's me. And the authenticator's like, eeps my jam, yo. And the client's like, hey, bro, let's do this. And the authentication server sends a cert to be, yo, I'm legit. And the client's like, cool, 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 I see it. Okay, okay, okay. And then here we go. And then the bros create an encrypted tunnel to keep it everything on the down low. And we're doing the tunnel. We got a tunnel. You send me a password over the encrypted tunnel like we literally just talked about, and the client says, you want my password? Here's my password somewhere in this hash. And the APs and the radio server's like, okay, okay, okay. The client's like, I'm waiting. And the client's like, give me a sec, hold on, I'm figuring this out. Come on, you're almost there. And okay, I found you in the database. The password is accurate. Step 1, 4-way handshake begins, sending you a made-up number from some stuff I know. I'll take your stuff, I'll raise your stuff, plus your stuff to my stuff to make new stuff. Here's a thing I made so that you can talk to everyone, the GDK, and then thanks, we're done. Artisanal encryption key activated. That's the whole process for EPOL, right? So something complicated we can make very simple by cleaning it up. I don't need to see a bunch of numbers here. Just tell me what the devices are. And instead of doing gobbledygook here, GDK, PDK, for you and me, that's awesome. For a customer, maybe not so great. I probably wouldn't show this one to my customer, but you get the point, right? The comments are free for you to put whatever you want. So when you want to learn something, put stuff in there that's easy for you to remember. When you want to show the customer something, put stuff that's in there that's easy for the customer to remember. So commenting is one of my favorite features in Wireshark because it makes something very complicated very simple, and I love doing that when I'm teaching stuff to people. How can I take something complicated and make it simple for you to understand? And then I think that's it. Let's see what else we got. Well, just showing you what I just did. And graphing. So the last thing is graphing. So graphing is also very cool because it gives you a visual representation of this tablature data. How am I on time? I got a minute. Okay, good. I'm not going to go over this time. Tablature data. So what we're going to do, I'll try to do this very quickly, is we're going to compare two different data sets, two different things. One of them, I was troubleshooting a site and customer was having problems with some phones. And so what I did was I saw that one type of phone was having a problem, a Cisco 8821, and another type of phone wasn't having so many problems. And that was that was actually a Cisco 7929G, an older phone. So what I did was, when I opened that packet capture, which I did here, I created, this was for the customer to see what I was talking about, I created a graph. So this graph shows all the data that's available in this file, all the data. Doesn't help me. I need to make some comparisons. So my first comparison is retries. So I'm going to create a graph filter called retries, and I'm going to give it a color of red. And I'm going to say, and I actually happen to have a retry filter here, so I'm just going to copy and paste that. So I'm going to steal that retry filter and put it in here. Boom. And now I'm going to go over here and call another one called 7929G. 7925G. And I'm going to say, I only want to see stuff from this device only, just this device. And then I'm going to give that a color of, I don't know, let's say green. We'll give it green. All right. And then, oops, I did the wrong thing. I wanted to give it the MAC address. So the MAC address of that phone. And now when I do that, I have a comparison of retries against that phone. And I can see, oh, whoa, that doesn't look so great. So retries versus the 7925G. Do I have the right one on? Oh, I deleted it by accident somehow. There we go. There we go. So now I can compare red retries versus what the phone is doing. And I can see it's relatively low. Not a lot going on there. But if I open up another one. Here's 8211, and I do the same exact thing, except I'm no longer looking for that phone. I'm looking for this phone. And then I put this in here. Well, that's a much bigger difference, right? Half the frames almost of this phone call are being retried. And when I saw that and I was able to look into the actual frames, I was able to see that, oh, there are problems with this particular call. If I do a filter for QoS frames, so it's just going to be the phone call basically, I can see here's the phone call. I can see that it is in fact using voice. It's marking the frames as voice. I can see things like the data rate, and then what's this? So if I start scrolling down, I start seeing some weird stuff. If I actually do this and I say, not only show me retries, show me that, and the WLAN address of the phone, I can see that between the phone, as I scroll down here, we're going to see something very interesting. Notice that we have everything is at the top speed for OneStream 11AC, 86.6, right? Cisco to the phone, Cisco to the phone, Cisco to the AP to the phone. Once the call starts and it starts going between the call manager, look at the data rates. Look at all these data rates. Every data rate is starting at 86.6, and all of a sudden we get these weird drops. And as I scroll down, you'll notice it gets lower and lower. And then what we're seeing is whenever the AP talks to the client responds at a lower data rate. And it went from 50 to 19 to 13, and eventually it disconnects and restarts the call. So what happened was, what I didn't know, and this exposed it to me, there was a bug. There was a bug in the Cisco software for the call manager that on these phones that it didn't like AMPDUs. So whenever AMPDUs were used, and that's what it used when it was making the calls, the phone said, I don't like this. I can't talk at 86.6. Let me try 54. Let me try 48. Let me try 30. And it kept working its way down until eventually it disconnected the call. And that's why we had so many retries, because the phone said, nope, I don't want, I'm going to send this frame again. Nope, this isn't working out. This isn't working out. Lower, 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 lower. And it could never get somewhere stable until it disconnected the call and restarted, and then we would have this process again. So that was something. Did it tell me what the problem was? Hey, did Wireshark say anywhere AMPDUs is an issue? No. But I was able to find out that there was an issue and then start inquiring with the Cisco people I know and say, have you seen this before? This looks really weird. The 7925G is 11A, talks 54 megs, always, every single frame, perfect every time. This 8821 cannot stay connected at that high data rate. What's the problem? Oh, it turns out there's a bug. You need to install this fix, and that fixes the problem, and boom, it fixed the problem. So that's my presentation for today. We can get deeper into that when we do the Wireshark boot camp or deep dive this week. Thank you.